Hello everybody, in this video we're going to talk about extraneous solutions in radical equations. So let's remember what the word extraneous means. It's just an apparent solution that does not satisfy the original equation. And so that's when we solve the equation and we take that solution and we plug it back into the original equation and it does not satisfy, right? So it appeared to be a solution, but once we checked our work, it actually did not satisfy the original equation. So let's look at this example here. The square root of x is equal to -5. So if we think about that, we are not introducing this square root here. So once we were solving quadratics back in previous videos, sometimes we had to take the square root of both sides. So in that case, we ourselves were introducing the square root. And so there we added, okay, this could be positive or negative of the square root. Well, here with these radical equations, the square root's already there. So the only way we can get only way we can take a square root is if we're taking the square root of a positive number, right? And so in this case, if we have the square root of x equals -5, we can't take the square root of anything and get a negative answer, okay? So let's look at these two examples down here. So the first one is x equals the square root of 20 minus x. So what we would do is we would square both sides so that we can get rid of that radical. Now, we are not introducing a square root here. We are squaring both sides. So only positive values are going to work for us. So now we have x squared equals 20 minus x. And I see this as a quadratic because I have an exponent of a 2. So let's set this equal to 0. So let's write this as x squared plus x minus 20 equals 0. So how did we get there? We added x to both sides and we subtracted 20 from both sides, okay? So now we're at this quadratic trinomial and we can factor this by thinking what two numbers add to b and multiply to c. So b here is 1 and c is -20. So these two numbers are going to be x plus 5 and x minus 4. So our two numbers there are 5 and -4 because 5 times -4 is -20 and 5 plus -4 would be +1. And so now we can use the zero product property and write x plus 5 equals 0. So x equals -5 and x minus 4 equals 0. So x equals +4. Now we need to check our work and we're going to check it back into our original equation, which was x equals the square root of 20 minus x. So now let's plug in -5. And when we plug in -5, we get -5 is equal to the square root of 20 minus -5. So -5 equals the square root of 20 plus 5, which would be 25. And now as we look here, you might think, oh, -5 times -5 is 25, right? But we didn't introduce this square root, so we only can take positive answers. So in this case, the square root of 25 is only 5, right? So this would not be true, which means x equals -5 is an extraneous solution, okay? X equals -5 is extraneous. All right, now let's check 4. So if we said x equals the square root of 20 minus x, and we plug in 4 here, and we plug in 4 right there. So now this is 4 is equal to the square root of 16, and that one would be true, right? So our only solution here would be x equals 4 and not x equals -5, because -5 would be an extraneous solution, okay? Now let's look at the second example. 7 plus the square root of 3x is equal to 1. So remember, let's use inverse operations to get that radical by itself. So I'm going to subtract 7 from both sides. Now I have the square root of 3x is equal to -6. Now let's square both sides, and we get 3x is equal to 36. We divide both sides by 3, and we get x is equal to 12, okay? Now let's plug 12 back in, so 7 plus square root of 3 times 12 is equal to 1. 7 plus square root of 36, well, the square root of 36 is 6. We only take the positive answer there. And this would be 13 is equal to 1, right? Well, that's not true. So in this case, x equals 12 was an extraneous solution. So what's our answer here? Our answer is there is no real solution. Okay? All right, and that's how you identify extraneous solutions in radical equations.